Welcome to ERC Tipsnology. In this video, we will be continuing the discussion about superposition theorem for two voltage sources, and I'll show you how to calculate for a branch current. Let's start. Let's say that we want to use superposition theorem to find the current through R2, and we have three resistors with two voltage sources. One of them has 1 kilo ohm, the other one is 500 ohms and 900 ohms. We have 7 volts for VS1 and 14 volts for VS number 2. Now, how do we solve this kind of problem? First, we draw the circuit with only one voltage source, and we will draw it like a series parallel circuit, and as shown here, we replace the other voltage source with a closed wire. There will no longer be VS2, and we will be having only VS number 1. Now we have here VS1 with a value of 7 volts with the 3 resistors. Now look, the circuit looks like a series parallel circuit, and we will find the current through R2. Let's call it as I2S1. We may use the current divider formula to find I2S1. We need to find current I1S1 to calculate for I2S1, and the current in R3 is I3S1, but we will not find it since it's not given yet. Let's write the current divider formula to find the I2S1. So the formula will be R over R plus R multiplied with I, and we need R2 and R3 here because they are parallel, and the opposite resistor to R2 is R3. And we will multiply the current I1 with respect to S1. Now we need to find I1 S1, and we can do that by equating it with the I total S1, and we can apply the Ohm's law to calculate for the current total, which is also the I1 S1. Now what's the formula for the Ohm's law of I total? It's equal to Vs over RT, but since we are using source 1, we have to put with respect to S1. But we don't know RT, therefore the very first thing that we have to do is to calculate the R total, which is the series of R1 with the parallel of R2 and R3. So we have to multiply R2 R3 over R2 plus R3 and add it to the R1. We have to consider the kilo ohms, and we have to change it to ohms to make it the same with R2 and R3. So all resistors must have the same unit. All resistors were written in ohms before calculations. You can see here we have the arrows for the ohms. This is very important to do. Now the R total S1, now we will use the calculator, and let's calculate it. 1000 plus open parenthesis, another open parenthesis, and let's put here 500 close parenthesis. We make sure that we use the correct parenthesis in our calculations. Multiply with 900 parenthesis again, divided by open parenthesis 500 plus 900 close parenthesis, and we got 1321.42. Let's try it again to double check. 1000 plus 500 multiply with 900 divided by the sum of 500 900. Yes, we got 1321.428571. We can just write 6 instead of 57, and this will be ohms. So let's write it over here. Now we can use the R total to get the ITS1, which is 7 volts for VS1 divided by the 1321.4286 ohms. We will be getting the answer in amperes. Remember that volts over kilo ohms will be milliamperes if we have kilo ohms, but if it is volt over ohms, it will be ampere. Now that we got the answer for IT and RT, we can now continue with the calculation of I2 with the current divider rule. So all of them are stated in ohms, and we got the I1 S1 5.2973 milliamperes, and we multiply this with the quotient between 900 over the sum of 500 plus 900. and we will get 3.405407143, but I'll be writing only up to 4 decimal numbers, 3.4054. Now that we got the I2 with respect to the source 1, let's cancel VS1 and let's keep the VS2. So I changed the VS1 with just a closed wire and kept the VS2, which is 14 volts. And we have the same series parallel, but this time the R3 will be series and the R1, R2 will be parallel. And we replaced VS1, as I've said, with a closed wire. So this is just a series parallel circuit again, but we can find I2, S2, remember, like what we did before with current divider rule, and IT and I3 will be equal to each other. And the current in R1, we can call it as I1 with respect to S2. Everything will be with respect to S2. That's why I have placed here open and close parentheses with the S2. Now, by current divider formula, we have R over R plus R multiply with I, and we just copy the two parallel circuit resistors, 1 and 2, R1 parallel to R2, therefore we can get it here. And the input current to the junction is I3, and we multiply it with the answer, and we take the opposite resistance, which is R1. That's how we find it. But we don't know I3, therefore we have to calculate first for the I3 S2 to get the I2. And by Ohm's law, we can say V over R, or VS2 divided by the R total with respect to S2. But I don't know also, or I also don't know what is R total. Therefore, let's calculate first the R total with respect to the source 2, and that would be the R3 in series with the parallel of R1 and R2. Now, going back to the parallel for two resistors, that would be the multiplication over the sum of the two resistors. And let's substitute the values here. 900 ohms plus 1000 ohms, or the 1 kilo ohms that we had before, they multiply with 500 over the sum of 1000 and 500. And let's use the calculator now to calculate this. Let's put 900 plus the product of 1000 multiply with 500 over the sum of 1000 and 500. And we will be getting 1233.3333. We can just write 4 decimal places for the decimal part or the fractional part. And let's substitute it with our Ohm's law. 14 volts this time divided by 1233.3333 ohms, we get volts over ohms will be amperes. So we got here 0.113513516, but I'll just write up to 6 decimal digit. You may write the current in milliamperes too, like what I did now. I just moved the decimal point to the left 3 times. Now, going back to the current divider rule, substituting the values of I1, R1, and R2, and the I3, S2 that we have calculated, that will be equal to 0.011351, then milliamperes, or 11.351 milliamperes, we will multiply it with 1000 over the sum of 1000 and 500. Be careful in using the calculator, especially when you have parentheses, because you might have error also when you get the answer. So my answer is 7.5673 milliamperes. That's our I2 S2. Now we can algebraically add I2 S1 to I2 S2 to find the value or final value of I2. And I2 S1 is going downward, I2 S2 is also going downward, so we can add them because they have the same direction. So let's add I2 S1 plus I2 S2, and that's your final answer for the I2. So we can put, of course, don't forget to put the unit. This is the superposition theorem of calculating for the current I2 of the resistor branch R2, and we got 10.9727 milliamperes or 10.973 milliamperes. So that's it for the calculation, which we can do easily if you know the steps in superposition. But just to be sure, we will be doing a summary of what we have discussed now about the superposition theorem. Let's have a revision or review what we have done before. So we are actually taking the problem is to find the current in R2 using the superposition theorem. And to do that, we have to calculate for IR2, or we sometimes call it I2, simply I2. So we use we draw the circuit again, and we use the current divider rule in order to get the main formula, which is I2 equals R over R multiply with I. And since the parallel in the first circuit is R2, R3, so we will have the answer as R3 over R2 plus R3 multiplied with the input current I1 to the junction. That's how we did it. And then after that, the problem is we don't have the I1 S1 yet, so we used Ohm's law to be able to get the I total with respect to S1. But we also don't know the R total, therefore we have to calculate that also. Remember that in series, the I total will be equal to I1, or this should have been I3. Yes, I1 equals IT. Now, with the series parallel formula for the R total, we got the answer, and then we substitute it back to the I1 S1, and then we finally get the I2. After that, we draw the circuit again. This time we canceled the VS1 and kept the VS number 2. And after drawing it, we applied the current divider formula to find the I2S2, and that will be then of course we need to get the I3S2 first, but the problem is we need to get first really the RTS2. After that, we can go back and substitute the value of RTS2, and we will get I3S2, and we will finally get the I2. Now, the last step is to add algebraically the two answers. So we have to choose between plus or minus, but since in superposition theorem, if the current have the same direction, then it will be like sign. We will put positive, and so I algebraically add them, and this is what superposition theorem is all about. Then finally, we got our answer of 10.9727 milliamperes. So thank you so much for listening to our discussion for today. I hope you subscribed and learned about the superposition theorem using two voltage sources in a series parallel circuit. Thank you so much, and have a nice day, everyone.